students, so in the previous class we have seen some of the functions, some of the important functions and their graphs. Clear? So in this class I am going to start your exercise 2.3. So every theoretical things which we have done in the previous classes, all those things I am going to use in this exercise 2.3. I have gone through the definition of relation, the definition of function, and I have discussed the condition for what relation and the condition for function. Clear? How the relations are going to be functions, that I have already discussed. Clear? So now we shall go for problems one by one. Which of the following relations are functions, and write domain, codomain and range. So they are telling, they have given three relations 1, 2 and 3. From these three relations they are telling which of these are going to be function. That means they are asking to verify the condition of function. That means the condition of relation which is going to be a function. Clear? So they have already given the relation, from that we have to check which of these three is going to be function and which is not going to be a function. Clear? Okay, see the first one. What is domain? Domain means the collection of first elements. What is codomain? Collection of the second elements. Clear? After being in a function, it's going to be in a range. Okay. So first let us check, is it going to be a function or not? Okay. As I said, how to verify it is function or not? We have to write the domain elements in one set, codomain elements in the another set, and we have to verify each element of the domain is going to be having an unique image or not. Clear? So first we shall write all the elements, all the first elements in that domain, that is 2, 5, 8, 11, 14 and 17. Write all the second elements in the second set. What are the second elements? 1, 1, 1. All order pairs have 1. Clear? So 2 maps to 1, 5 maps to 1, 8 maps to 1, 11 maps to 1, 14 maps to 1, 17 maps to 1. That means all the elements of the domain are having single image. See here. Every element of the domain is having unique image. That's no problem. But that unique image is same. Please understand this. All the elements of the domain are having unique image. That unique image in the codomain is same for all the elements. Are you getting my point? So see here, 2 has unique image, 5 has unique image, 8 has unique image, 11 has unique image, 14 has unique image, 17 has unique image. Clear? Then what is unique image? What is not unique image? That also has to be clarified. Suppose this 11 is having images of this kind. Then it is not unique. See this, 11 has only one arrow. Here 11 has 2 arrows. This is not unique. Here it has only one arrow, that is unique. Clear? All the elements are having single arrows. From 2 also there is one arrow, from 5 1, from 8 1, from 11 1, from 14 1, from 17 1. That means all the elements of the domain are having unique images. That's why the relation is going to be a function. Clear? Clearly given relation is function. Relation is function because every element have unique image. Clear? So now domain of this you have to write, codomain of this you have to write, range of this also you have to write. Clear? This is your rough work. This is not your solution. This is your rough work. Clear? So now I will write domain, codomain and range. See here, domain of this. Domain is 2, 5, 8, 11, 14, 17. 2, 5, 8, 11, 14, 17. Okay. Next, codomain, single element, that is 1. Codomain, single element, that is 1. Range is also again same, because output is a single element, that is 1. So that's why range is also same. Range is also singleton set 1. Clear? So that's why first relation is function. First relation is function because each and every element has unique images. Domain is 2, 5, 8. Codomain is 1. Range is also 1. Clear? So now I will go for the third one. Second one you take it as homework. Clear? Second one you take it as homework. You do this type of rough work. After that, all the elements are having unique images means this is going to be the function. If they are not having unique image, it's not going to be a function. If it is not function, there is no need to write range. Clear? Okay. So now let us come to the third one. Third one, first again you do that rough work. That is, write the first elements in the domain, write the second elements in the codomain. First element is 1. In the second order pair also it is 1. No problem. 1 is already written. Don't repeat it. 2. Okay. 1 and 2 are the 2 elements. There 3 and 5 are the 2 elements. See, 1 is repeated. That's why I am going to write only once. Here 5 is repeated. That term I am going to write only once. First elements in the domain. Second elements in the codomain. Clear? Okay. First thing. 1 maps to 3. 1 maps to 3. 1 maps to 5. 2 maps to 5. Okay. See students, here 1 is having 2 arrows. That means it's not unique image. It's having 2 images. One is 3, another one is 5. But in this case, all the terms are having unique images. See here, 1 is not having unique image. It has 2 images. One is 3, another one is 5. Clear? So that's why answer for the third one is, it is not function. It is not function. It is not function because, write the reason, because element 1 from domain is not having unique image. Is not having unique image. Clear? See this, one has 2 images. One is 3, another one is 5. Because of these 2 order pairs, it's not going to be a function. It's not going to be a function. But in the first problem, all the elements are having the unique images. That's why it was a function. So that's why we have written domain, codomain and range. But in the third problem, one is having 2 images. One is 3, another one is 5. See this, I have explained. With that problem, now you can write this. You can write this with that answer. But here, you don't write this diagram with this particular answer, because whenever answer is not a function, you need example. Whenever it is a function, you don't need example. For that you should write with definition. Whenever it is not function, you should write with example. So that's why with that theoretical part you write this. Clear? So then your answer is going to be the correct one. Second one, you take it as homework and try it on your own. Clear? Okay students. So now let us move to the second problem for finding domain and range of the following. Clear? So students, in mathematics or in any subject, there are two ways of preparing. First one, you practice by writing 10 or 20 times and you by heart it. And the second one, you understand it, then you practice for 10 times. Clear? In the first thing, what happens, you may practice for 10 to 20 times and you may by heart that particular problem, but when you go in the exam, if one or the two steps are not going to be remembered, means definitely you are not going to that answer. Definitely you are going to lose the marks. But in the second case, what happens, if you have understood that problem, if you know the knowledge of that particular problem, if you forget one or two steps, then also you can write it, because you will having the knowledge of that particular problem. So that's why I always prefer you for the second thing. That is, please understand it and you practice it. You practice and don't by heart it. Are you getting my point? So please understand the problem, because this is that kind of problem. This is not definition. Definition you can by heart, but in this particular case, you can't by heart the particular problem. You have to understand that particular problem. Then only you can answer in this type of questions. Clear? So with this simple note or this simple thing that you have to keep in your mind before solving this kind of problems. I will explain very slowly, bit by bit, because this particular problem takes more time to understand. Okay? So in this problem, what they are asking to find domain and range. Clear? So let us take the first one. See, these two are the real valued function according to our particular chapter. So that's why f is always from real numbers to real numbers. Clear? Because these two values are real valued functions. In our relations and functions, we deal only with real valued functions, as we all discussed before. So that's why I will take f from R to R. Here f is defined as what? F of x equal to minus of mod x. F of x equal to minus of mod x. Okay. Usually f of x is equal to y. That is the notation of function. X is domain, y is range. Please understand it. When a relation becomes a function, please understand it. Whenever a relation converts to becoming a function, that means whenever a relation satisfies the conditions of the function, that particular term is always written as f of x equal to y. In the previous problem, you have studied which of the relations are going to be the functions. In that case, if it is going to be a function, f of x equal to y is going to be written in the form of notation. This is the notation. Please understand it. Clear? This is the standard notation of function, writing function. Clear? Okay. So here y value is minus of mod x. Y value is what? Minus of mod x. Don't worry, I am not going to write it as y. I am going to take it as minus of mod x and I am going to analyze it. No problem with it. Clear? So this is the given, but keep in mind this is the standard notation of function. Clear? Okay. So f of x equal to minus of mod x. F of x equal to minus of mod x. As you all know, what is mod function? What is mod function? See here. F of x is equal to mod x, that is equal to what? X whenever x is greater than or equal to 0 minus x whenever x is lesser than 0. This is the mod function, right? I think this already we have discussed in some of important graphs, some of important functions and their graphs. There we have discussed it. Clear? So f of x equal to mod x, that is written as x whenever x is greater than or equal to 0. That means this is the value of domain. See here, this is the value of domain. Whenever this x is lesser than 0, that indicates this. Whenever x is greater than 0, that indicates this particular interval. And output is going to be the x. Whenever x is lesser than 0, here it becomes x is negative. Negative into negative will be positive. So in the both case, it retains its sign, that is positive. Clear? Okay. Now what happens? They are giving minus sign with mod x. If I write minus sign with mod x, what are the terms going to change? See here. F of x equal to minus of mod x. Now what are the terms going to change? These two terms has to be changed. That is minus x. Here minus into minus is going to be plus x. But these terms not bothered because they are the terms of the domain. You write them as it is. Are you clear? Are you clear with this particular terms? If you are not clear, please understand it. Mod function is written as x is greater than or equal to 0. Whenever x is greater than or equal to 0, output is x. Whenever x is lesser than 0, output is negative of x. This is the definition of mod function. But what they have done, they have given minus of mod x. That means they are multiplying minus sign to the mod x. If I multiply minus sign to the mod x, I have to multiply minus sign for this both. It will be negative x, it will be positive x. Because negative into negative is positive. Now, these two terms are your output. That means range. These two terms are your range. These two terms are your domain. Are you getting my point? These two terms are your range because they are the output. These two are the domain because they are the input. See here, what input you give here, that is written here. If x is greater than 0, we choose this. If x is lesser than 0, we choose this. Are you getting my point? So now what happens? If you see the domain, x is greater than or equal to 0 means towards positive infinity. X is lesser than or equal to 0 means towards negative infinity. That means domain equal to real number set. Domain equal to real number set. Clear? Because these two terms are the domain. Anyways, R to R, that's why R is domain. That doesn't make more toughness. Clear? Here x is greater than or equal to 0 towards positive infinity. X is lesser than or equal to 0 towards negative infinity. This is your domain, that is real number set. Now range. Range. See, from the domain, whenever you are going to give positive number, from the domain, whenever you are going to give the positive number, that means greater than 0, that becomes what? Negative. See, if I give 2, here that becomes minus 2. If I give 3, here it becomes minus 3. If I give 4, here it becomes minus 4. Are you getting my point? That means if you give positive number greater than or equal to 0, you get negative number. Are you getting my point? Next, if I give negative number as input, if I give minus 2 as my input, minus 2 is lesser than 0, what is my output? X. So what input you give, that output you are going to get. What input you give, that output you are going to get. Are you clear? If I give -2, output is -2. If I give -3, output is -3. If I give -4, output is -4. If I give +4, output is minus of that 4. Are you getting my point? So if you see this, if you give positive, it becomes negative. If you give negative, then also it becomes negative. That means what all the things you give, whatever may be the inputs for this, output will be always negative. Output will be always negative. Are you getting my point? Output will be always negative means what is your range? See here. If I give 0, output is 0, no problem. If I give positive number, it will be negative. If I give negative number, it will be again negative. That means it is going towards negative infinity. In both the cases, it is going towards negative infinity. You give 2, -2 output. If you give 3, minus is 3. If you give if you give 10, output is -10. If you give 100, output is -100. Like this you go towards what? Positive infinity towards domain. That means positive infinity as you go in domain, that converts towards negative infinity in your range. This is the domain. As you go towards positive infinity in domain, output will become what? Negative infinity in range. As you go negative infinity towards negative infinity in your domain, again it goes towards negative infinity in your range. In both the cases, it is traveling towards negative infinity. That's why open at negative infinity, closed at 0. Open at negative infinity, closed at 0. Are you getting my point? So domain is real number set, range is open at -infinity, closed at 0. So this is how you have to understand. Okay students, this all I have explained. From this, if you get the knowledge, it's very well and good. If you get the answer, very well and good. But please don't by heart this. Okay, you write all this by pausing the video. Here I will explain the shortcut method. Clear? First you write down this by pausing the video. There I will explain a shortcut method. That thing makes you feel more happy. Are you getting my point? Okay. For that shortcut, you must know 2 points. First one is, what is mod x? Mod x means it is always positive. See here. Okay, mod x we have already explained. Mod x gives always positive. Always positive. Clear? What is minus of mod x? This is always positive. Always positive multiplied with negative sign becomes what? Always negative. Over. Answer is over. See, mod x is our output. For that, always positive. We already studied. If I multiply this mod x with minus sign, it will be what? Always negative, because always positive sign multiplied with negative means we all know negative into positive will always remain negative. So this minus of mod x remains always negative. This remains always negative. Always negative means what? 0 to negative infinity. Always. See here, if this is your number line, this is towards positive infinity, this is towards negative infinity, this is 0. This moves towards negative infinity. Always 0. Sorry, always negative means what? 0 to negative infinity. That is what always negative. So that's why always negative means open at minus infinity, closed at 0. That's all. That's what your range. But this thing you must understand. If you understand these two things, it's very well and good. In exam, suppose if you forget this particular terms, or if you don't remember this particular terms, you write this much. It's more than enough, because they will ask it for either 2 mark or 1 mark. You write this much. As we all know, mod x is always positive. Minus of mod x will be always negative. Range will be from minus infinity to 0. That's more than enough. But this is the important thing that you have to understand. Clear? Okay, let us go to the next problem in the next class. Clear?